Hi everyone, welcome to my YouTube channel Intuitive Coding. So the problem of LeetCode today we are looking at is permutation sequence. So the question is pretty simple. You will be given a number n and number k. So for the number n, we'll have a set of 1, 2, 3 until n. And then of all of the permutations of these numbers, we need to return the kth element, given that all of the permutations are ordered. So for example, if n is 3 here, we have 6 different permutations, 1, 2, 3, 1, 3, 2 until 3, 2, 1. This list is ordered. Then if k is 3, we'll return the third number. If k is 5, we return the fifth number. If we have number n here, number k here, basically we want to know for the kth number, what's the first number of that permutation? What's the second number of that permutation? Until what's the nth number of that permutation? If n is 4, k is 9, how do we get the 2, 3, 1, 4 here? Let's first list out all of the permutations and see if you can find something interesting. So if n is 4, the list will be 1, 2, 3, 4. So the smallest permutation will be 1, 2, 3, 4. Second smallest should be 1, 2, 4, 3, because we want to use the smallest at the beginning. And third one will be, we have to put 1, 3 here. So then we have 2 and 4. And fourth number will be 1, 3, 4, 2. Fifth will be, because we already used 2 and 3, so 1, 4. And we have 2 and 3 left. So we have 2, 3, or 3, 2. So now you can see that starting with 1, we've used all of the 6 different permutations of 2, 3, 4. So we start with 2 now. So the first number, 2, 1, 3, 4. And then we have 2, 1, 4, 3. 13 should start with 3. 1, 2, 4. You can already see we always have 6 numbers starting with a specific number. So 3. The last number should be the last we can get from these 3 numbers. So it should be 4, 2, 1. Until the largest one should be 4, 3, 2, 1. So the total number of the permutations are 24. That's 4 by 3 by 2 by 1. Why? Because we need to determine the first number. We have 4 different possibilities. That's these 4. After we determine the first number, let's say we determine the first number is 1. We only have 2, 3, 4, these 3 numbers left. So to determine which one is the second number, we only have 3 choices. That's why we have 3. So you can see we have 6 different possibilities when we start with 1. Or start with 2, or start with 3, or start with 4. So we divided all of the permutations into 4 different groups according to the first number. And then we can see if we determine the first number, let's say it's 1, now we have 6 numbers here, because now we only have 3 numbers that we can use. So the combinations will be 3 times 2. And the 3 is actually the numbers of the blocks here. So the block 1, 2, or 3, determined on the first number of these 3 numbers we choose. And the same thing, after we determine the second number 2, we have 2 different options, either starting with 3 or starting with 4. K is 9. That means we need to know what's the 9th number. To know what number it is, we need to know 4 things. One is, what's the first number? Then, what's the 4th number? So how do we know what's the first number? Actually, you can see we have 4 different blocks starting with 4 different numbers. If we know which block it belongs to, then we know what the first number it is. And we already know we have 6 different permutations in each block. So if we can divide this number by 6, then we know how many blocks we can exclude. 9 divided by 6 will be 1. Remainder is 3. That means we can ignore the first block now because the first block has 6 numbers. So then we know this number should be in the second block. It must start with the second number here. So the index of the list is 0, 1, 2, 3. And here, this is the quotient is 1, is actually the index we want to get. So we know the first number is list quotient. And this one is the remainder. When the remainder is 3, that means it's the third number of the second block. In the second block, 1, 2, 3, 4, 5, 6 different numbers. And we want to know what's the third number. So again, let's now ignore the first number because we already know the first number. We have 1, 3, and 4 left. And these are 6 permutations of 1, 3, and 4. What's the third one? You can tell actually now we are asking the same question. At the beginning we have 4 numbers. We ask what's the 9th number. Now we have 3 numbers. We ask what's the third permutation of these 3 numbers. So you can think the question is n is equals 3 and k is actually 3 because we're asking about the third number now. Doesn't matter if the numbers in the list is 1, 3, 4 or 1, 2, 3 or 2, 3, 4. It's just 3 numbers. So what's the third number here? We do the same thing. You have 3 blocks, either starting with 1, that's the first number, or starting with 3, that's the second number, or starts with 4, that's the third number. So we have 3 different blocks, and we want to know which block is the third number in. So to address this question, we will use the same strategy, which is 3, that is a number here, divided by 2. Why 2? Because now the list is 1, 3, and 4. It has 3 elements, and we know 3 times 2 times 1. The 3 is the number of the blocks, and 2 times 1, which is number of permutations each block. So we divided by this, divided the 3 by this number here. And we also take the mode of this number. So the quotient now is this, and the remainder is this. And we get 1 and 1 here. So what does that mean? It actually means we can ignore the first block, which is here, because the remainder is not 0. So we know it's in the second block. And what's the number in the second block? We know that's this number. Happens to be, again, the index is quotient. Now the quotient is 1, and index is 1. So the same expression to get the exact number of that position. So we'll take this number out first, and then the list becomes 1 and 4. And the question is, what's the first number of the permutations of 1 and 4? Here we see we have 2 different possibilities, 1, 4 or 4, 1. And what's the first one? That's 1, 4. So actually we do the same thing. We use 1 divided by, so 1 now is a new numerator. And the new denominator will be the number of the permutations per block. So now for the new list, we have 2 times 1. 2 is the number of blocks again, and 1 is the number of permutations per block. So divided by 1. 1 mode 1. So you have 1 and 0. And now the quotient is this, and remainder is this. So this 1 is the denominator. you can already find that the numerator starts with k and then get updated by the remainder, here 3, here 1, in each round. And the denominator is always the number here, which is the permutation numbers per block. When we have a list, we can get the length of the list. And this number is always length of list minus 1. We take the factorial of this number. We use this as the denominator every time. So what happens when the remainder is 0? So what if we get a remainder of 0 at the beginning? Let's say instead of 9, the k is 6. So we know 6 is this number here. That's the last number of the first block because we have 6 numbers in the first block or in each block. So if we take the k, 6 at the beginning, and we divide it by 6, we know it's 1. And the remainder is 0 because it can be divided. So what does that mean? If the remainder is 0, that means this number is the last number of the first block. We know two things. 1, we know the first number is 1 because all the numbers in the first block starts with 1. That means the rest numbers are 2, 3, and 4. If the remainder is 0, that means that's the last number of the first block. So we know that all of the permutations are ordered, so the last number in the first block should be the biggest one. So that means it's pretty simple. All of the combinations consist 2, 3, and 4. The last number must be 4, 3, 2. So we directly know this number should be 1, 4, 3, 2 because we know the first number is 1, and then the largest number we can get is 4, 3, 2. That should be the last number of the first block. So let's generalize this idea. We have an n, we have a k. So we first import the math because we need to calculate the factorial. And then we initialize the result as an empty string. And the rest list, so at the beginning it's just 1, 2, 3 until n. And we initialize the numerator, as I said, as k. That's the case number here. As long as the length of the rest list is greater than 0, which means it's not empty, we'll do the whole thing. So first, we know the denominator is the factorial of the length of rest minus 1. So what we do here is we calculate the quotient, and then we calculate remainder. If the remainder is not 0, we pop out the index of quotient from the rest, add it to the result, and update the numerator using the remainder. If the remainder is 0, that's perfect because we know the number must be the last number of the block. So we just take the first number first. So quotient minus 1 because that's the last block. And we pop it out, add it to result. Then for the rest, we just take the biggest number first and then second biggest until we take all of the numbers from the rest. And then we return the result. The code is accepted and beats more than 80% of the submissions.